Hello everyone, this is Tony from ETC 295 Applied Projects Lab course. I will be going over my course project for the Applied Projects Lab in this PowerPoint presentation. Introduction. In the ETC 295 Applied Projects course, I chose to construct, test, and document an adjustable power supply using a LM317 voltage regulator in its original form for my course project. The object of the power supply is to change the AC signal given from a wall receptacle to a usable variable DC signal. Here is a list for the parts that will be needed in the construction of the adjustable power supply that we will be talking about for this course project. These parts can even be found for low to no cost at your local electronics dealership, on the internet, or even right in your own home. Now keep in mind that these are only the core components, and you will need to have other materials such as a chassis, electrical power cord, and a transformer, just to name a few. Okay, circuit function and operations. The power supply contains a step-down transformer that changes your AC voltage from the 118 volt AC wall receptacle to a lower input voltage to be rectified and then filtered. The power supply should have a rectifier that will be used to convert the negative cycle on the output of the transformer or to make it a positive cycle. The filter portion of your power supply will then smooth out the pulsating current from the rectifier with the use of filter capacitors. Okay, one of the key features to this circuit is the LM317T voltage regulator. It has a voltage in, a voltage out, and an adjust. It is an adjustable 3-terminal positive voltage regulator that is able to supply more than 1.5 amps over an output voltage range of 1.25 volts to 37 volts. It also provides current limiting and thermal overload protection for the circuit. It requires the use of both R1 and R2 to set the output voltages. Okay, here's a basic power supply block diagram. It shows the AC line voltage coming into the primary of the transformer. On the secondary of the transformer, you have your rectifier. For this specific power supply unit, we're going to be using a full wave rectifier or a bridge for rectification. The next section will be your filter, and after that will be your voltage regulator that we talked about, and this job is to stabilize and regulate the output voltages seen on the output side of the power supply unit. Multi-simulation. Okay, I think this was the hardest part of building this power supply unit. In the beginning, all I had was one DC voltmeter and a potentiometer, but I wanted to try and construct a power supply unit that would have both a voltmeter and an ammeter on the output side of the power supply unit. Okay, I knew the only way to do that, I needed to have my voltmeter wired across the output of the power supply unit, and my ammeter that I later got to be wired in series with that voltmeter across the output of the power supply unit. Okay, now the issues that I was having was the current that is felt on the output side of the power supply unit is in microamps, and the ammeter that I had gotten, it wouldn't register a current that low. So I had to try to come up with a way to, to monitor the current. I know that we use the potentiometers to measure and control voltages, and rheostats are for your current meters. Okay, I had to do a little bit more research and take a lot of individual voltage and current readings using a multi-sim program. What I ended up finding out was that I could use the one potentiometer that I had. I could wire that up like a rheostat, just using 2 of the connections of that potentiometer, of that 5K ohm potentiometer. I didn't need all 3 of them. Multisim let me know that by placing an ammeter, by connecting one side of the ammeter up to the movable or adjustable arm of the potentiometer, and the other side of the ammeter to the potentiometer, and it doesn't matter which side that I chose to pick. I was able to monitor the current that was being seen inside of the circuit, and multisim let me know that, hey, if I did it this way, I would get a higher current reading, be milliamps, and then that was the type of meter the ammeter that I had. Also with that, I still have control of the voltage, monitoring the voltage across my output and increasing and lowering the voltages with that potentiometer, but at the same time still monitoring a steady current level of the current that we're seeing within inside the circuit. Also, since this circuit is using external capacitors with the IC regulator, you will notice that the protection diodes, which are D1 and D2, are used to prevent your capacitors from discharging back into the regulator due to a sudden short circuit that could happen on the input or the output, or back EMF that could be caused by an inductive load inside of the circuit. Circuit analysis. Oscilloscope shows an AC sine wave of 24.8 volts at about 59.52 hertz to the input of the power supply. Meter faces show 5 volts at 5.3 milliamps DC on the panels. Oscilloscope after the bridge rectifier showing a ripple or pulsating DC level on that waveform that's seen right there. Oscilloscope showing a steady, smooth DC voltage level output. Okay, the DC voltage level output is 28 volts at about 1.3 milliamps. Conclusion. There are many different applications and uses for power supplies, since there are different kinds of equipment that all have different power requirements. They can be constructed to provide a specific power output, or they can be built to give multiple different power outputs for different pieces of equipment. They help in preventing power failure, as well as providing a steady DC voltage input for computer operations and all other electronics such as communications equipment. Without having power supplies, all of our electronics that we use will have a very hard time getting the specific voltage and current requirements needed for them to operate properly. Okay, these are the reference sources that I use to compile this PowerPoint presentation. This concludes the end of my PowerPoint presentation. Thank you for watching. Take care.